Modularity is a reason for which we provide an environment that allows process cooperation. So modularity means we want to design a system by dividing it into separate modules. Okay, so these modules may be designed by different persons, and finally we'll put together all these modules to work and to achieve a single goal. So these modules need to communicate or cooperate with each other. So that is one of the reasons for cooperating processes. The fourth reason for cooperating process, for having cooperating processes or establishing cooperation among the processes, convenience. That is, if we allow the process to cooperate with each other, then that becomes very convenient for the users. Example, a user may be using a system and may be doing different tasks at the same time. He may be listening to the music, maybe typing a document, taking a printout, etc. concurrently, and so there should be a cooperation among these processes for the smooth working of all the processes. So these are the reasons for providing an environment that allows process cooperation. Next, how we can achieve inter-process communications, or what are the methods by which we can provide inter-process communication. So the cooperating process, they need a mechanism by which they can share the data among each other. So basically there are two methods to achieving this. One is by shared memory and second one is by message passing. So in shared memory, what we do is a portion of the memory can be shared by all the process which are cooperating with each other. So they will exchange the information by reading and writing data to the shared region. So whenever one process wants to communicate with another process, it will write the information it wants to share onto the shared memory. The other process can read the data written by the first process from the shared memory, and then it will understand what is actually the first process was trying to communicate. Whereas in the message passing model, communication takes place by means of messages exchanged between the cooperating processes. So there are messages which help them in communication with each other. These messages are exchanged between process, and communication between process take place in the message passing model. So this is the diagram for shared memory as well as for message passing. So the figure A shows the diagram for what shared memory. So here we can see that we have two processes, process A and process B, and in which process A is trying to communicate with process B. Okay, so there is a shared region in between process A and process B. When process A wants to communicate with process B, it will write the information into the shared memory, and process B will read the information that was written into the shared memory by process A, and it will understand what the communication A was trying to make. So by help of a shared memory region, process A was able to communicate with process B. Now look into the second figure, that is figure B for message passing. So we have two processes here also, A and B, and here M indicates messages. Okay, so process A is trying to communicate with process B, and here we doesn't have any shared memory. It will, when process A wants to communicate with process B, it will send message to process B. Okay, so how the process being delivered to process B, we first process A will create the message and will pass it to the kernel, and the kernel will get the message, and it knows the messages for process B, and the kernel will send the message to B, process B. Okay, that is how the process A gives a message to process B. So here we doesn't have any shared memory. Instant process A will send the message to kernel, and the kernel in turn will send it to message B. So that is message passing.